In this video, we'll move on to make a new map that utilizes data that we create independently in Excel and in the ArcPro app. The basic idea will be to recreate with fake data some of the height modernization maps that I've made previously. In order to get more exact heights on our base stations, we've had to take check shots from a few control points around the state and determine distances to our base stations to get those heights exact according to the modern standards of NOAA. We'll go through a couple of steps here to create some fake data for our height modernization map. First up, we'll set up a new map in this project, and then we'll make some fake data in Excel concerning the points for our base stations and control points. We'll import that from Excel into ArcPro, and then we'll create some data that connects those points directly in ArcPro. After that, we'll calculate the lengths for those connections, and we'll also make some labels. We won't be making a layout for this particular map because we've already made a layout for our MoDOT districts map, and making a layout is more or less the same process every time. Let's get started with a new map in the same project. We could also create a new project, but I want to have all of the data and maps for this video series in a single project document. We'll go through all of the normal steps to set up this map. Firstly, we'll give it a name. And we'll set up our normal UTM coordinate system. And we'll also choose a base map. In this case, I think I'm going to go back to the light gray canvas just to show as little as possible that's going to conflict with the actual data that I'm trying to show. The next thing I want you to do is set up an Excel document with the headings lat, long, ID, and elevation. I've already set up my Excel document and pre-filled it with a couple of, again, fake values. You can either copy this data or you can make your own. Just keep in mind that if you want to have your data land within the state of Missouri, you should be choosing latitudes between about 36 and 41, and longitudes between about -89 and -95. That may not get it exactly in Missouri, but it'll get it in generally the correct area. You do need to have that negative in front of your longitudes, because if you don't, it'll land in the Eastern Hemisphere, somewhere in Asia. For ID, I've gone ahead and just given it the names of the cities that those points are approximately in, and then elevation is approximately correct for elevation in feet, but not exactly correct. We should go ahead and treat this as not real data. If you've got all your values entered and you're ready to proceed, save this as a .xlsx format. You may have worked with Excel data previously in ArcMap and had to save in a .xls format. With ArcPro, we're upgraded, so we can now use the current version of Excel's document file format. We can use the .xlsx format instead of .xls, so that makes things a little bit easier. I went ahead and saved this in my project folder. Now, if you did like I did and saved this in your project folder, it'll already be there when you open it back up. If you already had it open in your catalog pane, you may need to hit F5 to refresh that to get it to show up again. If you saved it outside of your project folder, you'll need to add a folder connection. Just hit this button and navigate to the folder where you've saved it so that you can add it to your map. Now you'll notice here that there's a little arrow beside the XLSX format. That's because within ArcPro, every sheet is going to be modeled as its own independent table. Of course, I only put data in one sheet there, so all we have is sheet 1. I'm going to go ahead and add this to my current map. And I'll open it just to make sure all of the data looks right. A unique object ID has been added when I opened this in ArcPro, just so that ArcPro can keep track of these data. In order to get this to display as points on our map, we need to right-click and display XY data. The input table is already correct. We know that we do want points. It's very hard to get lines or polygons to come through from Excel data. It should automatically detect if you put the headings in there that you have a long and lat field, which correctly are set up as the X and Y fields. Latitude is south to north, so that's up and down like your y-axis, and longitude is east to west, so that's left to right like your x-axis. The last thing you'll need to set is the coordinate system. Now you may be tempted to just set it in the UTM since that's what we're mapping in, but you should not do that because UTM by default is in meters, and you put your XY data in the degree format, so you need to choose a coordinate system that uses decimal degrees and not meters or any other linear unit. What I recommend is going in here to geographic coordinate systems, North America, USA, and territories, and then choose NAD 1983-2011. That's the geographic coordinate system on which UTM is based, or in which the UTM system that we commonly use is based. And so your decimal degrees, I should say, will coincide correctly with your linear data that's based on UTM. You hit OK there, and the tool will run, and then it will zoom you into where your points popped in. I've put all my points down here in south central Missouri, mostly clustering around, I believe, the town of St. James. If you want, you can export this using the data export features. That's not strictly necessary anymore. In the latest version of ArcPro, when you display XY, a feature class will already be created in your home geo database. So if you want those to be a shapefile somewhere else, you want them to have a different name or something, you can export it, but it's not necessary. The next thing we're going to do is make our observations that connect these points. How we're going to do that is go over to geoprocessing, and we're going to search for the create feature class tool. We'll create it directly in our home geo database, and I'll call it observations. Although since this is fake data, it doesn't really matter what it's called. We'll make a geometry type of polyline. That's pretty important. We don't want to have the 2D polygons or the 0-dimension points. We want to have 1-dimension polyline data. There's no template data set, and we will say that these don't have M or Z values. And for our coordinate system, we'll go back to putting these in UTM. We could project our points to UTM, but I'm not going to do that because it's not necessary. We'll run that, and the feature class is created. It appears here in our contents pane. Of course, the There's nothing on the map because there is nothing in this feature class. By default, it is completely empty of real data. So to create some data in here, what we're going to do is go to the Edit ribbon and hit this Create Features to open the Create Features pane. You'll see that we can create in either of our data sets that are currently added to our map, but we want to create in observations. Before you do anything, make sure that you've got snapping turned on up here so that you can snap directly to your points so that they will coincide exactly. And you can just draw some lines connecting a few of your points. Again, it doesn't really matter because we're just making some fake data. If you are done with your line, you can either hit this button to lock it in, or you can double click at the last vertex you want to add. Then when you're done, just go ahead and clear your selection, save your edits, and we'll just hit the select tool to get back out of our data creation tools. The next thing I want to do is create some line lengths for these observation lines. We'll open up the attribute table here, and you can see there's already a shape length field, but this is obviously in some very small unit because those aren't super long distances, so this is clearly not in miles or kilometers. When we're doing the real height modernization, we often want to know these in kilometers, so we'll go ahead and create a field for length in kilometers. Let's just call this length _in_km, and we'll just set an alias to length. For our data type, we want double or float. Double or float are the only data types that can take a decimal number, so it's very important that we have one of those. I'll choose double because it can take a slightly longer number. And then we'll save that field, close out of our field view. Now we've got this separate length field here, and to get data in there, what we're going to do is right here below the regular calculate field, there's a calculate geometry. That allows you to get things like length, perimeter, and area directly into your attribute table so that you can, say, calculate things like population density, which we'll do in a later exercise. Here we want to set the property to length geodesic and our length unit to kilometers. Our coordinate system is going to just be UTM. We might want to choose a different coordinate system or choose more carefully if we want very exact lengths, but I don't care very much about very exact lengths here, so just the UTM that we're working in is good. And this calculates automatically. Now we have somewhat more reasonable values for those. However, these go out to a really long decimal place, and as I mentioned, I don't care about being super exact, and this probably isn't accurate out to these last decimal places here anyway. What I want to do is round this off to just one decimal place. How we do that is to go back into our regular calculate field, and we can write a short expression to do it. Instead of doing Python this time, we're going to try out Arcade. Arcade is a unique programming language just for Esri and the Arc products, which can allow you to do a lot of things like manipulate your data or change what's being displayed based on manipulations of your attribute data. To round, all we have to do is type uppercase round. That turned green, meaning it recognizes it as a function. The current length, by double-clicking there, comma 1, which means one decimal place, end those parentheses and just hit apply. And it'll automatically round off the lengths for me. Now let's just put some labels on this map so that I can see what we're looking at. Real quick, we'll just go to points, labeling, and label based on ID, since those are our city names. And then we'll go to observations and label those, and we'll label not on shape length, but just length to get those nice rounded off lengths in kilometers. Now right away I noticed that these are just numbers, just bare numbers, and that means that if someone were looking at this map, they wouldn't know whether those were, say, kilometers or miles. So what I'm going to do is attach the word kilometers to the end of this, and how I'm going to do that is by writing another arcade expression here. And that arcade expression is very simple because we just take this feature length in kilometers plus km. It's important to have km in quotes there so that the system knows that you want it to take it as text. And you'll notice I also put a little space there. That's important because if you put a space there, then a space will appear on the label. And if you don't put a space there, then there will be no space on the label. Hit apply, and the kilometers marker shows up right on our labels in our map to make things less ambiguous. One last thing I'll do real quick is just put those halos back on because they're a little bit hard to read right now. So we'll just put 2-point halos, and we'll put them on the points as well. And now I would be ready to move on to creating my layout. But as I mentioned, we've already created a layout, so we'll just skip over creating a layout for this particular map. And instead, in the next video, I'll show you how to use some of the new 3D capabilities in ArcGIS Pro to make a 3D version of this map.